Hi, in this video we'll be talking about how to sketch rational functions and how to find the domain, the range, the vertical asymptote, and the horizontal asymptote. All right, we're also going to be focusing on how to use the TI-84 calculator to help us, but we're going to look back, just in case you want a refresher, we're going to briefly look back at a way to figure these things out without the TI-84 as well. All right, so first of all, focusing on the TI-84, in order to sketch a function, remember you always start off by going to y equals. So we go to y equals, and I actually put these parentheses in for you here, but note that most of the times when you see these questions, you won't actually see those parentheses. Whether or not you see those parentheses when you're graphing in your graphing calculator, you should definitely put them in to show the calculator that you're grouping the numerator together, expression together, and grouping the denominator expression together. All right, so let's go ahead and type that in. We have 3x, and the x is right here, plus 1, and then we close that parenthesis to group the numerator, over, open another parenthesis, x minus 2, and we close that. Now we graph it, and it should come up showing two asymptotes, a vertical asymptote and a horizontal asymptote. So just to remind you what an asymptote is, I'll show you the bigger picture here. An asymptote is a line that the graph approaches but does not touch. So if I trace along here, notice there is a line, we can't see it, but there is a line horizontally that the graph is approaching but not touching, and I'm trying to trace that line there. There is also a vertical line that the graph is approaching but not touching. That one is actually easier to see. So let's start off there. All right, so in order to figure out what the domain is from left to right, notice that over here, the graph is going infinitely left. Over here, the graph is going infinitely right off the page. Now, it starts over here, or it starts infinitely that way, but we can keep going, keep going. It's almost everything. X can be almost everything, but it jumps from here over to here. It skips one particular value, and the value that it's skipping, we can figure out by looking at the graph and actually seeing where that line could go, and assuming that our asymptote is a whole number, we see that if we try to draw a line at 1, it wouldn't work. It would cross over the graph right here. If we tried to draw a line at 3, it wouldn't work. It would cross over right here. And if we try to draw a line at 2, it's perfect. So the vertical asymptote is at x equals 2. Okay, so let's write that down, and then let's talk about why we don't need the TI-84 to figure that out. We can actually do it without it. So let's see. The vertical asymptote is at x equals 2, which means the domain, the graph can be anywhere except 2. So the domain is the opposite of that, which is x is not equal to 2. All right, great. How could we have figured those two things out without looking at the TI-84 graph? Well, we could have looked at the equation, and you may recall a rule. You may have known this rule for a long time. Maybe you don't remember. In the denominator of any fraction, we are not allowed to have a 0. We are not allowed to have 0 in the denominator. Now, if you notice, if you look here, if you put a 2 in this place here, that would make the denominator 0. So 2 is not allowed in that spot. So we could have just set our denominator equal to 0 and solved for x to figure out what x cannot be. So x cannot be 2 because the vertical asymptote is at 2. All right, great. Now let's look at the horizontal asymptote, which will help us figure out what the range is. All right. So my power is super low, so I'm talking a little fast. All right, so if we were to draw a line at 1, notice it would cross over the graph. If we were to draw a line at 2, it's a little bit better, but it's still crossing over here. If we were to draw a line at 3, assuming the horizontal asymptote is a whole number, it looks like it's at 3. Let's check on the other side. Drawing a line at 3 looks pretty great. All right, so I know actually the horizontal asymptote is at 3. If we tried 4, it's going to cross over on the right side. All right, but you may not want to eyeball it, and I don't blame you. So how can we figure out what the horizontal asymptote is if we're not going to just be eyeballing it on the calculator? Well, what you want to do is figure out, let's actually get a sketch in here. You want to figure out what's going to happen when x is really, really, really big. All right. So when I say when x is really, really big, imagine the graph goes on and 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 on to the right and to the left, but I'm going to focus on going to the right. This is going to flatten out, approaching a certain number, but never quite touching it. So what I like to do, here's a little trick I like to use. I'll tell you two. The trick I like to use is to make x really, really big. If you make x really big, let's say you make x 1,000, then you'll see what the behavior of the graph is all the way over to the right. Okay, so let's make x 1,000. If you make x 1,000, then in the numerator we have 3 times 1,000 plus 1, which would give us 3,001. And in the denominator, we would have 1,000 minus 2, which is 998. And when you divide 3001 by 998, you'll get a number that is almost, not quite, but almost 3. Even if we made the number a billion, the numerator is always going to be slightly larger than the denominator, but it's never going to it's always going to be slightly larger. You're always going to get something slightly larger than 3, but you're never going to exactly get 3. And that's how we can tell that our horizontal asymptote is at 3, because our graph is approaching that but never quite touching it. So our horizontal asymptote is at y equals 3, and our range where the graph is everywhere except y equals 3. So y is not equal to 3. All right, and that's how you approach these questions.